Today, we as a nation face many challenges as our consumption of gasoline increases. Dependence on foreign oil from unstable areas of the world creates challenges that threaten national security as well as our economic stability. While ethanol alone can't solve all of these challenges, it does play an important part by helping to extend our fuel supply. Ethanol is an oxygen-enhancing fuel additive produced by starch fermentation. With over 80 million acres of corn produced annually, this renewable energy source meets the needs of automobile manufacturers and the petroleum industry. Recognized for its cleaner burning characteristics, it also meets the demand for cleaner burning fuel additives mandated by the federal government, resulting in an industry production rate of over 2.5 billion gallons annually. Welcome to Midwest Grain Processors, the flagship of the ethanol industry's new generation ethanol plants. A cornerstone in a field of opportunities industrial park, MGP benefits from the strategic location of Farm Direct top-quality corn, Northern Border's natural gas pipeline, and rail distribution advantages from the Union Pacific Railroad. Cutting-edge technology, coupled with one of the most productive growing regions in the world, equates to over 45 million gallons of denatured ethanol produced yearly, or enough fuel additive to send the average car for 11.25 billion miles. This type of volume requires 16 million bushel of corn, or a staggering approximate 50,000 bushel per day. All corn delivered to MGP undergoes quality monitoring by federally licensed independent grain inspectors. Maintaining control of inbound grain quality maximizes plant conversion efficiency and minimizes potential infections that are costly. 2 grain dump pits with a capacity of 15,000 bushel per hour keep the corn flowing and ultimately distributed in these 200,000 bushel silos. This capacity provides MGP with a 5 to 7 day supply in case of inclement weather. A state-of-the-art control room and laboratory is the heart of the entire operation. A 24-hour control system monitors all processes and product flows. Laboratory personnel monitor the process for conversion of starch, production of alcohol, and quality of the end products. Corn is comprised of starch by weight at 65 to 70%, germ 6 to 7%, water between 14 and 16, and fiber at 10 to 12%. Corn is fed into a grinder called a hammer mill that provides a consistent, smaller sized particle or flour that exposes the starch for processing. Liquid is then added to create a mash and the first step in the cooking process. The temperature is then increased to liquefy the starch in the mash while enzymes are added to break down the starch to long-chain sugars and ultimately produce glucose. The mash is now cooled and transferred into large fermentation tanks where yeast is added to start the fermentation process and converts the sugars into alcohol. This process takes about 45 hours with the final stage set in the beer well. Carbon dioxide is a byproduct of yeast fermentation. A CO2 scrubber entrains the vapor alcohol in water and returns it to the process. The fermented mash is separated from the alcohol in the distillation and dehydration process. Water and spent solids are then removed for the purpose of purifying the alcohol to a sellable product. Alcohol is flashed or heated to 170 degrees in the first column or beer column, where the vapor is captured at the top of the column while the solids are pumped from the bottom to a holding tank. The second column or rectifying column separates high-proof alcohol from water as the alcohol is flashed again to a vapor at 170 degrees at the top and lower proof alcohol is pumped out the bottom to a side stripper. The side stripper separates low proof alcohol from extra water based again on the 170-degree flash point, while the water falling from the bottom is pumped back into the cook process for reuse. This process results in 190 proof or 95% alcohol, but there is still another step. The alcohol is then pressurized through a molecular sieve or series of beads that allow water to be absorbed. Because the alcohol molecules are too large to enter the sieve, 200 proof alcohol flows through to a tank ready to be denatured, loaded, and shipped to a refinery or gasoline distribution hub for blending. The remaining water is recycled and used once again in the cook process. Efficient and cost-effective transportation of the final product is key to MGP's premier status as a volume supplier that is able to meet the demands of the petroleum industry. A private fleet of leased tank cars gives MGP the ability to reach into any destination with cost-effective ethanol and is unsurpassed in the industry. Truck capabilities allow MGP to react to local demands for fuel ethanol as well, always ensuring that the best priced product makes it to the most needed destination. Spent grains from the remaining mash are processed in a centrifuge that condenses the solids into a wet cake with a moisture content of approximately 65%. Wet cake has high nutritional value in the livestock market, allowing for the product to be a source of protein as well as energy at feeding or nutritional values equal to or better than that of whole corn. During this process, the liquid or stillage that is removed from the spent grains is evaporated to remove the excess moisture. The thickening of the stillage produces a byproduct called syrup that contains 30 to 40% solids. This product is applied to the wet cake during the drying process, thus giving the byproduct name, dried distiller's grains with solubles. The wet cake is then dried to a 10% moisture using large rotary drums to provide high quality dried distiller's grains with solubles, which are used in a variety of feed markets. Midwest Grain Processors is more than just an ethanol plant. The employees, members, and management have positioned themselves to be a driving force in the global energy market. We're producing better, processing better, profiting better. Midwest Grain Processors, ethanol, and more.